Welcome to our webinar, Open Software Defined Automation Part 1, The Evolution from Hardware to Software. This webinar is sponsored by Schneider Electric and Automation.com, a subsidiary of the International Society of Automation. I am Renee Bassett, Chief Editor of Automation.com, and I will be your host. As digital information sweeps across industries, industrial automation and control systems are evolving away from hardware-dependent mechanical systems to software-defined automation, or SDA paradigms. With control logic decoupled from the physical devices it runs on, operational technology, or OT systems, can be more programmable, flexible, and scalable. Users of SDA OT systems enjoy many strategic advantages, especially when the software they use is based on open standards rather than proprietary systems. To understand this new way forward for industrial automation systems, Automation.com developed this 4-part webinar series in partnership with Schneider Electric. Through conversations, presentations, and demonstrations, we'll explore the evolution of SDA from Schneider Electric's point of view, see what successful uses of open software-defined automation look like as well. Today in Part 1, I'm talking with Andre Babineau, Schneider Electric's SDA Country Director. He will provide an overview of what software-defined automation means, how it differs from legacy systems, and what advantages it can deliver now and in the future. We'd like this to be an interactive session, so we've built time in to take your questions. You'll see a questions icon on your screen. Simply click in the text box, enter a question, and hit send at any time. I'll serve up your questions to Andre at the end of our discussion and ask him to respond to as many as possible while keeping the overall presentation time to 1 hour. Any questions we don't get to will be answered via email. This entire webinar is being recorded, and we'll email you with a link so you can watch it again. So now, welcome, Andre. So glad to be talking with you today.
Yeah, thank you for inviting me here, Renee. I'm really excited to talk about a dear subject, which is software-defined automation and how it can bring us to the next level of automation.
Excellent. Before we dive into the topic, could you please tell our audience about your experience with process automation systems and your current role with Schneider Electric?
Yeah, definitely. I've been in the industry for about 30 years. I started my career with known of Foxborough solution, and which was also known under the name of Invensys, which I played different roles from engineering manager to pre-sales director. And after leaving Invensys, I joined a company called CAE in flight simulation and software solution to redesign an instructor station using modern user experience technology for flight simulators. And just prior joining Schneider Electric, I worked as a pre-sales director as well, and at Velan, which is a valve manufacturer here in Montreal, and again trying to get closer to the industrial automation again. And then I joined Schneider in different role, and the primary role I had was to go and define this new future solution that we call EcoStruxure Automation Expert. And now I'm the country director to continue the journey of software-defined automation here in Canada.
Excellent. Well, your long experience with automation and control systems means you know what it's like to have hardware capabilities determine what an industrial system can and cannot do. Can you describe for us what those early systems were like and some of their limitations?
Absolutely. And I've been through those. I've been with this long career. We've seen the evolution of an industrial automation coming from mechanical system, pulleys and relays, and all of this started to be migrated to what we know of today, a PLC, which was a mean to replace this logic of relays into a more simple or more programmable way of doing things. And we've seen the same thing with all the measurement. We used to measure with pneumatic instrumentation, which was extremely complex and precise and mechanical. And we moved that to a more electrical, to 4220, and then it evolved to what we know as digital protocols today. And all of this was probably controlled from a massive panel with all these different instruments were. And this moved slowly to electronic single loop controller and eventually to what we call today distributed control system, or DCS. all of these different systems that in the past that were hardware driven were really strong hardware differentiator from vendors to vendor, and that's how you selected the different solution. But this strong differentiation came really to high cost for the end user because this solution was extremely proprietary from a solution and maintenance perspective, but also was extremely complicated to change anything. Imagine trying to add a new loop or change a loop to a traditional single loop to a type of feed forward or things like this. It was extremely complicated to change those panels because it was all mechanical work that needed to happen, and it took weeks, if not months, to modify any of those. So really, this was the challenge that the industry faced, and slowly moving to those new technology allow us to bring a little bit more flexibility.
Well, the software and information systems have been integrating into these mechanical and hardware systems for quite a while now, too. What kind of time period are we talking about where software became more dominant, and how did that evolve into our?
Yeah, and definitely. I've seen some of those because at the beginning it's really the rise of making those solutions more programmable. And that's what we've seen some electronics come into play instead of a mechanical system. But all these, even though they're electronics and more flexible and more programmable, they were designed on bespoke operating system and bespoke hardware design, and makes it a lot specific to each of the vendors and really tedious to maintain and trying to have those systems to communicate with each other. So we start seeing a little bit of embedded software and hardware controllers. We've seen also in the late 90s a little bit slow adoption of standard IT solution like Unix platform for non-critical solution, and eventually even Windows came into play from a human machine interface where there's no critical operation or real-time operation. So we slowly saw the adoption of IT technology in the OT space, but that came really at a really, really slow pace. And we can draw an analogy to the music industry that kind of went through the same thing, starting with the LP and the vinyl with their dedicated turntable. And after that, we wanted something a little bit more portable. So we went and invented the cassette that allowed us to bring the music with us. It was a lot more portable. We can bring it to the car, play it even on a Walkman, and we carried it with us. That was the epitome of, I would say, portability at the time. But this continued to evolve where even digital came in with the CD player. But again, the CD had a specific format with a specific player. So there was still a hardware dependency. And really the change really came when streaming came along. And now this is where you started to design your own playlist, and you can take that playlist and play it anywhere you want it. And that's really where we start seeing the changes in the music industry for sure, but also we'll see also that it can also be applied to our industry. Breaking the strong bound between the hardware and the software is really the next phase of where OT is going.
That's really interesting. I can see how that analogy really fits with where our industrial systems are today. Can you tell me where this fits in with what we're calling Industry 4.0 and the continued evolution of systems?
Sure, certainly. Industry 4.0 has a lot of elements of new approach to factories. The big thing is about the smart factories, right? We envision in Industry 4.0 the factories where machine and system are fully integrated and work seamlessly with communication between the devices, making this mesh of IIoT or Industrial Internet of Things, where basically now you have a mesh of solution or devices talking to each other to bring a higher level of automation. So all of this data and all this meshing of Industrial Internet of Things brings a lot more data. And that's what we heard the expression big data that came from also from the IT industry. But it's the same thing in the OT. We generate a vast amount of data that can be analyzed to gain insight and make informed decision. And that's where today, that's where we're going into. And that's why we're seeing new technologies being AI and machine learning being applied to the OT space. And that's really where we see this convergence of IT and OT coming together. And that's why also the software-defined automation, as we see it, will come into play to really bring all of this together. Industry 4.0 will increase the productivity and efficiency. And when we talk efficiency, we can also talk about sustainability that it brings to the end user and how it can bring more efficiently new product line, because the market are changing rapidly, which was not the case nearly 30, 40 years ago. Now markets are changing, so the customers and end user has to change rapidly. So these types of solution really helps our end user to achieve what they're looking for, to leverage the data to increase their production, but also automate all this data that they have and how they can leverage it to make sure they have better production and better yield on their processing plan. It also increased flexibility and agility. The smart factory that we're talking about can respond to those changes that we talked about. The market are changing and asking for different types of specification on the product. So by understanding those parameters and understanding the data we have, we can better meet the requests of the market in a much faster way than we used to. It creates more flexibility for the end user, but also to the market to bring new solution, new product at a lot faster pace than we used to be able to do with those mechanical, which takes months and years to change. So really all of this bring together is really this combination of software and hardware and leveraging IT into the space to really bring more agility, flexibility, and interoperability in the market of OT.
Mm-hmm. Excellent. So let's talk about the open part of open software-defined automation. What do you mean by that? And are there different types of open systems? What are we talking about? What is that bringing to the table?
Absolutely. Open is used quite openly, I would say, in the market today. There's a lot of definition about open. And we've seen some specific initiative in the market. One of the one that was created in 2014 is Open Process Automation Forum, which is really trying to bring the industry together to try to define a solution that will make it interoperable, and in the sense that different parts, different components from different vendors can work together. From our perspective in Schneider Electric, what we see as open is really how we can bring some interoperability and portability, which is also important in this case, to the actual runtime, what runs those processes. So basically, we were founding members of what is called universalautomation.org, which is an organization that promotes this common runtime. And basically, it's available to all the members of universalautomation.org to take this runtime and implement it in their controller, making now this mesh a lot easier to maintain, because this runtimes allows intercommunication without any configuration, simplifying the life and the configuration and the maintenance of system for our customer. So these are the different aspects of what we see as open. And part of this, as being founding members of universalautomation.org, we also launch our own solution called EcoStruxure Automation Expert that leverage that universalautomation.org runtime in our solution, bringing a lot more openness to our customer.
I see. Well, let's talk a little bit about what the strategic advantages are to end users, and end users in particular, but also the software vendors who support them in terms of moving to this new paradigm, open software-defined automation.
Absolutely. There's definitely strategic advantages to move to this software-defined automation. We talked about a little bit how we decouple the software and the hardware, and really what it allows us to do from from an industry perspective, which is probably the single largest challenge that the industry is facing today, is obsolescence of those automation systems. Most of these automation systems are probably 15 to 30 years old, and it's quite a challenge to take an existing solution and move it to the next generation to remove that obsolescence from a hardware or even a software perspective. From our perspective, this challenge to be able to remove obsolescence at any given time without interrupting the production is a key advantage of software-defined automation. The other element that we bring also to our customer, and that's a key element, is what we call the power of choice. Now we bring to the customer the ultimate solution, or they can pick the ultimate solution for their specific needs. Because typically when we buy, or when an end user buy a solution, he does buy typically a vendor, I would say, because if he picks a solution, a software solution, the hardware comes with it today. Or he picks the hardware, the software comes with it. One way or the other, they always bundle together. What we have done now is give the power of choice to customer to select the software that he likes and fits his need exactly, and the same thing for the hardware. And this open software-defined automation allows us to bring both together and making sure that it meets the needs of the customer. So it's really a unique advantage that now the customer has that never had before. Now you can choose the specific solution and not basically select a vendor. The other advantage we see for the future is really the software defined is the foundation for what we call autonomous operation. We've seen a lot of challenges in this autonomous operation. Obviously, it's all started when we started automating the process, which is something we've been doing for the last 60 years by developing different strategy and making sure that process always optimally produce and yield the maximum production for our customers. But also what we've seen is that its autonomous operation is quite complex, because what we see is that not only you need to automate the production, but you need to automate the system. And today the system typically rely to make sure it's performing to its maximum to the knowledge of the workforce that we have in our plants, in our production facility. But as we know, the workforce challenge today, there's a lot of that knowledge is moving to their next phase of life and retiring for their production. So basically, this knowledge to optimally tune the system is not there anymore. This software defined allows us to take that knowledge and bring into the system to make sure we optimally fix this solution and the system together with the process. And those two together with the optimal system solution and the optimal process solution, now we can start looking at this dream of having only a man and a dog to control those plants. And the last piece that we have that is critical in this is to have something that's application-centric. Our customers are really about producing whatever they're producing, their product, right? So what we're looking for them to do is really focus on that application, to say, this is what I need to go control, and do not get bogged down by the architecture of the solution behind it. And it's a little bit the same if I go back to this music analogy. When we build our playlist, we don't think where we're going to play it. Is it going to be on my iPhone? Is it on my PC? And based on this, I'll change my playlist? No. We select the music as we feel we need it, and we want to do exactly the same with the application-centric. The customer should not take into consideration where it's going to be played and how it's going to be played, but he needs to understand what he wants to produce. And that's the application centricity that makes EcoStruxure Automation Expert so unique in the market today.
Very interesting. It sounds like there's been quite a number of advances, and it also sounds like that people are doing it right now today. It's not just all theoretical and pie in the sky. Can you tell me about industrial users who have implemented these solutions and the tools that they're using?
Absolutely. As you know, EcoStruxure Automation Expert was introduced 5 years ago now. And about a year later, universalautomation.org was launched as well. And what we've seen now is an adoption in the energy and chemical market. We have large customers that now have deployed this solution in their operating plant and discover how much it brings a new dimension to their process automation and how it can, there's a new reality that it can aim for that they never seen before. Also, there's new industry like chemical plastic recycling, which is developing a new process to make sure that we take care of all these plastic garbage in a new way. And they're really looking at this solution being software defined as being a key element to bring flexibility to these new processes, because these new processes are evolving as we go. As we learn more about how to do this chemical recycling, they need to be able to adapt their production. And we've seen a great adoption in those markets as well. There's highlight of measurable improvements, really, and what we've seen in feedback from our customer is how easy it is to troubleshoot and find challenges when they occur, instead of taking a lot of time to go and scrutinize the programming. Typically, such a solution like EcoStruxure Automation Expert allows you to pinpoint directly the problem and solve it rapidly. And if it's a system solution, a system problem, our solution can resolve some of the problem automatically, bring this level of autonomy we talked about. What we've seen also from these large energy and chemical customers is how fast the implementation and installation can become as it's software driven, and everything can be tested and use software tools to bring this implementation to life a lot faster. So this is where we stand today, and it continues to evolve and interest continue to grow. And that's where we want to continue to push in this market.
So let's look ahead a little bit. What's next for these types of systems, and what's possible with open software-defined automation?
Yeah, definitely a great question, because we're just at the infancy of software-defined automation perspective. But one of the things we see that software-defined automation will bring is this drive towards more autonomy that we touched base a little bit. It is a key element for a customer to see how they can bring more autonomy for different reasons. They did develop the process autonomy, and they know how to manage their process. We're introducing system autonomy by bringing more system solution. But all of this is in one of the challenges they're facing. We talked about the obsolescence of the solution, but there's also an obsolescence in the sense that the workforce is transforming. We have new skills coming in that need and looking to be applied, but also we got the exiting workforce that exit with their knowledge of the system and keep the system running optimally. So now with the software defined and the drive towards autonomy, we're trying to bridge the two together. And really what we're trying to do with this autonomy is push what we call state-based control at scale. Because what we would like to see with the autonomy is something as simple, not just start up and shut down procedure, which is also state-based control. But now we want to go bigger and wider, because the systems and all the big data that we collected, that we talked in Industry 4.0 that can brings with IIoT and AI and machine learning, allows us to brings more autonomy. And when we talk about state-based control at scale, we're looking at to say, what if the customer can just say, today I want to run maximum yield, or I want to run with minimum energy consumption. So by having those type of state, it will enable the customer to bring a lot more flexibility to their production line, meeting their requirements, being from an environmental perspective, from a sustainability perspective. And really, this is where we see the software-defined automation brings more value to our customer. And the other thing we're seeing in this is that we'll see more and more software-defined everything. We already seen in the IT industry the software networking. So basically, that's something we will see also in the OT space coming to us. So more and more, we'll see software being part of the solution that our customers are being exposed to. So really a call to action, I would say, is the upskilling of our resources and workforce, but also the mindset that we need to change when we start looking at an OT control system. It's not the old control as we talked about pneumatic and relay logic. Now we're way past this, and now we need to embrace this new change of software defined and what it can bring. So that's a key element. Remove the blockers and try to embrace this new technology and making sure software defined and a solution like EcoStruxure Automation Expert becomes successful in the market.
Excellent. Thank you so much. And now it's time for questions from our audience. As a reminder, use the questions icon at the top of your screen to submit your questions. We'll get to as many as we can, and those we don't get to will be responded to via email. Also note that the materials icon at the top of the screen contains a downloadable PDF. In it, you'll find links to Schneider Electric's Guide to Software-Defined Automation, and also more information on EcoStruxure Automation Expert. So we do have some questions coming in. Andre, are you ready for our first question from our audience?
Absolutely.
Excellent. Let me see. Where is it? What I would like you to, the first question we have is, can you provide some steps that organizations can take to begin this transition? This is a paradigm shift. It's a brand new thing for a lot of people and a lot of companies. And so what is the best way to get started down this road?
Absolutely. That's a great question. So obviously, not everything will happen all at once. Not everything will become software defined from one day to the other. It's really a step-by-step approach. But really, with EcoStruxure Automation Expert, we allow you to take that approach step by step. As we're fully software defined, you can just get the software and start designing your application, play with the tool, and test that application all and only with the EcoStruxure Automation Expert. All is integrated. You don't need the hardware to be able to test. As we've seen and explained, is the hardware is totally decoupled, so you can basically build your whole application, test it, play with it, and when you're satisfied with it, then determine what type of architecture you're looking for. Because with an EcoStruxure Automation Expert, you can decide to go to a distributed architecture where you can distribute across multiple controllers the application you built, or you can decide to centralize, as we see most of these things being done today. Depending on the architecture you choose, there is no impact to your cost or your software. Really, what we're looking for is that application only. So it's size based on your application, not based on your architecture. Again, this is the proof to decouple the software from the hardware perspective. So really, step by step, you're going to build your application with our software, minimal investment. You try it, you test it, and you start small, and then you start testing in your real life plant when you see probably some obsolescence in some of your installation. And obviously, you want to integrate this solution in the rest of your existing architecture. Obviously, you can do it with multiple open protocol like OPC UA. So this is the way I would approach it.
Excellent. Thank you. Next question. As software-defined automation decoupled control from hardware to enable flexibility, how do we balance this advantage with the need for deterministic performance and robust cybersecurity in this environment?
Absolutely. Again, extremely good question. Regarding determinism and the performance, this piece really on the software or the runtime software. And what we provide, and as we discussed with universalautomation.org, any members of that organization can get access to this runtime and then apply it to their actual hardware controller. So as long as they follow the rule, the same determinism will apply for any of those runtime distributed across those different types of platforms. From a cybersecurity perspective, EcoStruxure Automation Expert, being a brand new solution, was built from the ground up with all those new cybersecurity challenges in mind, and is now certified SL2 by 62443 by TUV. So basically, you have now with EcoStruxure Automation Expert a fully certified solution. Obviously, you might say there's also components in the hardware that enable that cybersecurity, like trusted platform module, which is true. So looking at the recommendation from your hardware perspective, you got to make sure you have these solution embedded in your hardware. And you can also look to, if you want to push it a little bit further, for device onboarding, the solution like FDO, which is FIDO device onboarding, which basically it's a zero-touch onboarding, cyber secure zero-touch onboarding. So that's what how I would approach those two elements here.
Got it. We have a question about the openness aspect and what other vendor platforms might be supported in this open environment. And do you ever see other PLC vendors like Siemens and Rockwell potentially joining universalautomation.org?
Excellent question. And again, if you look at the universalautomation.org platform, you will see all different vendors, about 50 of them, if I'm not mistaken. And some of them are directly playing in the field and provides controller already in the marketplace. You have Phoenix Contact, you have Omron that is there. You have other players like Honeywell. You've got also Yokogawa, Andress and Azra are there. So the direct OT players that have already some offers on the market. So it's already available. And if you look at universalautomation.org website, you will be able to find all these different vendors that have an offer on the market.
And I just want to take the opportunity to let our audience know that we do have a part 2 of this webinar presentation. Do you want to say anything about what people can expect in that part 2, where we'll be talking about the importance of open systems?
Definitely. The next conversation that we will have is what are those open standards that we find in automation? And obviously, we will be joined at this time with members of universalautomation.org to explain what are the open standards, what is the value, and what does is the impact of the open standard in automation, and how it has change the lay of the land and how it's changing. But there's still other activity coming up, and Schneider is a strong participant in most of these open organizations in the market today.
Great, thank you. Another question from our audience. With people comfortable and familiar with ladder logic disappearing and the current generation learning high-level languages, is the time coming where an IPC running Python or something similar will be controlling the process?
That's an interesting question, and it's really a programming language question. I think it's your preference that will drive this, and how you want to see your solution going forward, and how you want it to be maintained. Obviously, as we know, Python is a more modern language than what ladder logic is, but both can deliver the same solution and the same performance in our solution. And we do support most of these programming language, and it's just a selection of your choice to make sure that you can achieve the level of maintenance and level of performance you're looking for.
Okay. The next question. In the music streaming analogy that you gave, the quality of a speaker can vary. The quality of the sound is thus determined by the quality of the speaker. When deploying a hard real-time system to a robot or other device, how can you be sure the application can run in a guaranteed time window?
Absolutely. That's a good question. And here, the time window is an interesting concept, because the time window is really when you're bound to a cyclical approach to your control strategy. And here with Automation Expert, we look at events. So if nothing happens in the process, we're not necessarily bounded by this time, and the event will occur to generate the necessary action. So it's a little bit of change in the current way of thinking and looking and how we develop our control strategy. But really, it allows you to achieve a lot more and simple um, integration of different solutions. And if we look at the market and how the different markets evolve, and as we know, we're leveraging a lot of IT solution. And here is quite interesting because the latest and greatest or the latest direction in IT is really to develop event-driven architecture. So really, we're right there with the IT industry for that purpose and really making the integration an even lot easier.
Got it. Next question. As you implement this solution, starting small, can you tie into the larger existing proprietary hardware-driven solutions as you transition to a software-based solution?
Absolutely great question. I thought I was trying to answer it a little bit earlier, but really what happens is you're going to start small, like I said, and you mentioned it here, and you're going to have this island or smaller system, and you want to be able to share that information in that smaller system to the larger implementation or the previous installation. And this all can be done with any of the protocol that we know of, and the one I mentioned is OPC, which is fairly widely adopted today in most of the solution. And if the solution that you have currently doesn't support it, we have a lot of different protocols that allows us not only to integrate with systems like this, but also on the IT side. So we have a lot of different types of solution that can help you integrate the EcoStruxure Automation Expert to your existing platforms.
Got it. You talked earlier about the challenges of obsolescence. Can you elaborate a little bit on the obsolescence topic, either regarding hardware or the people and skills involved?
Absolutely. That's a great topic because obsolescence, as well, it's probably the most challenging problem that any end user have or facing today. Because most automation systems out there are probably between 10, 15, 20 years old, and even more than that for some of them. And the obsolescence is really challenging because now you need to understand what are you going to do because you probably don't have necessarily from a hardware perspective and the form fit replacement for a failed device that you may have that is coming. And also, it might be problematic from a software side because maybe that software is not supported anymore. So, how do you keep it running? So, all these aspects are quite challenging today for any end users. What we bring with open software defined automation is at any time you can update the hardware with the latest and greatest as we're totally agnostic to the hardware platform. So, you don't have to wait for a cliff event where the hardware is not available anymore. As you see it's getting older and maybe there's some challenges with your current hardware, then you can replace it, even waiting, taking a shutdown. So we do have solution that allow you to basically change some of that hardware and that software, because as we know, there's a lot of maintenance from a software perspective and it's being challenged quite a bit from an OS update or even cybersecurity patches that we've talked a little bit earlier. With EcoStruxure Automation Expert, we do provide solution that allows you to do all these elements, changing your hardware without taking shutdown, updating your software or cybersecurity patches, all of this without any human intervention. So this is a key element with EcoStruxure Automation Expert that will allow you to make your system evolve over time instead of waiting that total obsolescence and then the full rip and replace. So you'll be able to continuously update your software and hardware to make sure you're always at the highest performance level.
Got it. Another person wants to know if you have available demonstration software that folks can play with before they make a decision about investing in the platform.
Absolutely. We do have demonstration licenses that you can download and get access to our website. And you can get in touch with your Schneider representative to get access to it. And then you can try, we can support you in that trial to make sure that you understand all the different concepts. And then when you're ready, as we said earlier on, you don't have to buy hardware for that demo. You just play with the software. You can fully test your application, see the different elements of how this platform EcoStruxure Automation works. And then when you're ready, you can convert that license and have your application ready to be downloaded to your selected hardware.
Got it. Another person asks specifically for advice specifically for PLC programmers. Can you recommend how to begin this new learning path for this paradigm? What would be some resources from the PLC programmer perspective?
That's a good question. And yes, there is a lot of training available from our website. So basically, you can get some of the training. You got some training that's also available from a YouTube perspective. And also, if you want to really push it and understand further, there's some university that are part of universalautomation.org that offer courses directly on these paradigm and these concepts. So there's multiple access depending on how you want to go and learn and how deep you want to learn what this technology can do for you. So you can start simple with a small YouTube and just show you the trades a little bit, how to do things. And then you can go deeper at what it means to be event driven and so on. And if you really want to become an expert, you can basically register in some of those classes that exist in university.
Perfect. Thank you so much. I want to remind our audience that you can download from the materials icon at the top of the screen a sheet with specific links to the resources that Schneider Electric has available and various websites. So feel free to do that at any time. Let me see what other questions we might have. One additional question is about open systems specifically, and what is important about the idea of openness at this time? And what can you say about how this sets us up for the future?
Absolutely. And this is a key element from an open perspective. Really, what we're trying to do with our customer is really give them the power of choice, provide them back the solution they're looking for, and they can design the architecture. So really engaging them in the solution. And then they, in this open ecosystem, they can select what they perceive as being the best fit for their actual plan or control or machine to make sure they address to the specific point that they want to address. So really this openness just basically brings the best of a little bit of everybody together into an ecosystem and a solution. You can look at it a little bit like the Android system, right? Yes, you can have an Apple, and if you need something, you'll call Apple and you'll get what they have. But you can go to Android, which is going to basically offer you a lot wider and a lot more variety of solution that may fit exactly the need that you have. So really, this is kind of the approach. So basically, you have an ecosystem in which you can play and basically have the best fit for your actual solution you're looking for.
Perfect. Well, we are just about out of time today, so I would like to offer Andre a chance. Are there any closing remarks you'd like to give to our audience today before we sign off?
Absolutely. This is a great journey. And as you've asked, is start the journey, demo, download the demo license, start playing with it. We'll be here to support you. But join this revolution. And I believe it's really a revolution in the OT space now, where basically the end user become, again, in charge of their solution in the sense they can decide how it will be architected and will support the different open aspect to make sure we bring the best solution to the market. So really start your journey with EcoStruxure Automation Expert and see where it can bring you. So thank you for all the question and thank you for this, Renee.
Oh, thank you, Andre. It's been a pleasure talking with you today. I've learned a lot, and I'm sure our audience has too. I want to thank our audience for attending today and remind you that if you missed any portion of this webinar or want to watch it again, our discussion will be available on demand. Within the next 24 hours, you will receive an email with a link to the recording. On behalf of automation.com and Schneider Electric, I thank you for your attention, and this concludes our presentation.